Colin O'Flynn, welcome to the Security Ledger podcast. It's great to have you on.
Thanks so much for having me here.
Yeah, it's great. So I reached out to you because you're going to be a speaker at next month's Black Hat Briefings in Las Vegas, and you're going to be presenting a kind of updated version of a presentation that you gave on this really interesting hack you did of your oven to solve a really naughty problem that you had identified with the software that runs this device. So we're going to talk about that. But before we do that, Colin, tell our viewers / listeners just a little bit about yourself and, the company you founded, NewAE Technology.
For sure. So I started my background maybe at the beginnings all electrical engineering, really. So I know, security is a great space because you get people from all over. I'm terrible on network security, for example, but my real love is electrical engineering. I started on the other side doing wireless protocols, Zigbee IP, and all the sort of IoT stuff. Honestly, when it was called wireless sensor networks, and it was just a cool research domain, it seemed. That spun me into security. I saw a talk by someone, Paul Kocher, that was part of this guy that, so he really started this field of side channel analysis or side channel power analysis, I should say. And even some timing attack work, of course, he did. But it was like, it's amazing. Like devices are leaking information. So they run a cryptographic protocol and it seems like it shouldn't work. But just by observing the power used by the device on very, very fine scales, you can see differing number of bits going across the bus and stuff like that. So that is really what pivoted me, to be honest. As part of that, I did research in the area, so I did a PhD in it and built tools that I was using for my research. And the tools were all about taking measurements effectively, doing it with open source. And the point of that is that for researchers, it's really nice to have reproducible tools. Coming from the engineering side, I also lots of engineers that would say like, oh, these attacks aren't, or you need a PhD to do them. You need all this equipment. Which wasn't true. And the point of the company I started, NewAE Technology, was to make reproducible equipment that, researchers could use, but also engineers could use to interface with researchers. And I guess it turned out, it's like everything in life, a lot of luck in a way that it was right at the time there was more interest in hardware security. So we did a Kickstarter on this Chip Whisperer Lite, which was, one of the implementations with the hardware. Since then we've grown. So there's about 6 people full-time here in Canada, 5 of us in Halifax, 1 in Ottawa. And since then, actually, now we joined last year Low Risk CIC. So there's a UK community interest corporation, they call it. I describe it loosely as a nonprofit. So they have an open source RISC-V processor, IBEX, and they also are the main proponents, or they're sort of overseeing the Open Titan project, which is this open source root of trust. So it's really cool to see this interest, in open source, not just for good feeling, but because, there's real problems it's solving. In my case, the problem of making sure equipment is accessible to people, right? And not just accessible by cheap, but accessible by you can actually modify it, right? If you're a researcher,
right,
you can do anything.
So Chip Whisperer, talk about what it is. Is it hardware? Is it software? Is it both?
It's a bit of both. So the original idea of it was kind of this full platform. So if we're doing side channel attacks and fault attacks, you normally, the kind of setup I would always show is, if you bring a paper up, it's like the researcher has in their lab. So at the university, for example, we had a really nice oscilloscope that's worth like $200,000. And you don't need that oscilloscope, but it's just what, they bought on some great grant one day. And so the problem I found is that when you go to recreate stuff, the researchers obviously using this super nice oscilloscope. And so I tried to make hardware that could replace the oscilloscope so that you could have a package of, hey, here's the software, the hardware, everything, right, for doing a power or fault injection attack. So physically, as a reference, I happen to have, this was a later revision, but, on video, there's a little box that does the power measurement and fault injection. And then typically there's some target that's a reference, microcontroller that runs firmware or something like that.
It doesn't look like it cost $200,000.
No, right, exactly. So that's the thing. So yeah. It was, the first version we were like $250, and then we kind of have spread out between upper and lower. So now it goes from 50 to 4,000, depending on variants.
And who's the customers for NewAE, and what types of people in your experience are interested in this using Chip Whisperer, and what types of things are they using it for?
So we kind of have like a split of customers. Some of them are, strictly researchers in terms of classic academic, right? Using it to test a new algorithm, or they post quantums are a good example. There's lots of post quantum algorithm testing work, um, testing new attacks, things like that. It's roughly a third. We kind of have this third split between that. A third split is sort of what we call commercial, and this is typically engineers, right, that are working at a company, and they simply say, "Hey, we should recreate these attacks to test our stuff." And then a third of it tends to be more like penetration testing, security companies, or some government labs, which are doing similar work, right, as penetration testing on internal systems.
You've been interested in kind of hardware engineering design, as you say, kind of in your LinkedIn profile, since you were like 10. So like as a kid, this is something that you were just kind of fascinated with, and you had the Radio Shack hardware and all this stuff. What's your take on embedded systems, particularly, we're going to talk about your oven work, particularly in the sort of consumer space, the retail space, the stuff that's being sold into, homes and small businesses, the engineering culture or the engineering processes and kind of status quo that's producing all this stuff.
It's interesting because, if you think of engineering in general, right, if you think of engineering, maybe you think of building bridges or something like that, where it's very strict safety requirements. And so in Canada, for example, especially we have, the professional engineer, which you'd have liability. So if I designed a poor bridge, like I can go to jail because I, designed it not to the standards it should be. So it's really interesting in software because, we have computer engineering programs, which are supposed to have similar amounts of, things taught to engineers, but then I think what you see is that it doesn't feel the same, at least to me, right? The level of sort of rigorous code review is not always applied in that way, especially on consumer, appliances, because cars, for example, have a lot of standards around safety and what they actually have to do and some testing they have to do. And you could argue if that's effective or not, whatever, but it's there. Right. But like this oven, for example, that I looked at, it has a microcontroller that's controlling the heating element, and it's always wired to a 240 volt, 40 amp circuit. Yep. If that just turned on when I'm on vacation, what happens? Like, hopefully the oven is physically capable of surviving that. I don't know. Right. I don't know if that's tested, but it's just firmware that turns on the heating element. So,
and there isn't the same regulatory attention to that aspect of the device's operation. And I would say the same, I think, is really true with, you mentioned automobiles. Like, yes, there are safety requirements for automobiles, but I'm not sure they actually extend to the software that's on automobiles these days, because we're seeing a lot of really scary stuff, and there does not seem to be any consequences for the automakers about the scary stuff that's coming out. Let's talk about your kitchen and your oven, because this is, again, going to be the focus. Some really interesting research is going to be the focus of your talk at Black Hat. First of all, how long have you had this oven? What type of oven is it? And what was the problem that you became aware of with this oven?
So it's an old Samsung oven. It was with the house when we got it in 2016. And
right.
I'm sure it was 10 years older at least, based on, what I've seen.
Yeah.
And so it has, and a lot of ovens do this feature where
gas oven, electric oven?
It's electric. Yeah. So electric oven.
Okay.
And when you turn it on, it goes into preheat mode, and it shows you the temperature as it's heating up.
Mm-hmm.
And then once it hits the set temperature, it just displays the set temperature.
Mm-hmm.
And you have no idea what the actual temperature is. So you can put an oven thermometer in to see. And we had noticed that it would kind of go off temperature pretty heavily. So it would say it was 375. It was actually at 250. And either you have a thermometer in there, or if you reset it, it'll show the right temperature again. Like you turn it on and off, right? It shows the right temperature again. And so you can see like, oh, this thing's way off what it should be.
So if you were to shut the oven off and then turn it on, then the temperature would reset to what the actual temperature inside the oven was.
Exactly. So the logic seems to be basically that while it's below the set temperature, it's displaying the actual temperature until it crosses over, and then it never updates it again. It just says 375, right? So if it's below and you reset it, then it's going to realize, or not, it knows the whole time, but it's going to show you.
And with something like baking, that becomes a real problem.
Yeah. Yeah. And I mean, we really noticed it when we did a turkey one year, and it took, it was like, oh, this should be done, but it's not even close, right? It's like an hour late now.
And you got guests sitting there kind of twiddling their thumbs at the table.
Yeah. Well, luckily it was just us that year, okay. But then we got dogs. That was the photo in the talk is, like, what the hell? We're going to be begging here. But, yeah, right. I mean, for a lot of people, I'm sure they've had this frustration. But
yeah. So when you encountered this problem, did you like hop on the customer support forums and try and figure out like what the solution is, or if there was a fix or a setting you could adjust or something like that?
I did, yeah. So there's a few settings you can try recalibrating it, and there's some settings on convection, that'll automatically drop it. So it was none of those. And to be honest, I didn't think too much of it until there was an article from another guy in Halifax. He actually had an oven fire. And then in that article, they mentioned, oh, there's this, someone's trying to do a class action lawsuit against Samsung for this group of ovens, including mine. And they list all these complaints that are roughly the same. The temperature's way off, sometimes high, sometimes low. And they're blaming the thermometer. These are the lawyers, I think, are just picking out an item and saying, oh, the temperature sensor is defective. Which to me, it seemed like it wasn't, because if you reset it, it shows.
Right. It seems to be a software issue, right? The way
exactly
temperature is being read and figured into the operation of the oven. So you talked to your wife and said, I need to pull the oven out from the wall for a week or two.
Well, so I did. I bought a spare control board, because it seems like a bad idea to.
Even before we get into that, like, was there, like, when you went to look into like what's going on with this oven, was there information that you could get, like schematics and service manuals and stuff that helped you kind of understand how the device worked?
Yeah, there was a service manual, some of the sites that sell them type thing. So I was able to get a service manual. You found a number of people complaining about this as well. We didn't end up getting a repair person in, because when I was looking, a lot of people said, oh, they'll just try swapping different things out. And, it's not, it seemed to be just like, unless the thermometer is wrong, but I could tell that wasn't it. The heating element could be broken, but it seemed not to.
So in your head, you were like, this is a software issue.
Yeah. And to me, it looked a lot like, if you've worked with PID controllers before, it looked like this isn't really tuned well, because it's kind of working, but, it's like spiking and then going to the wrong temperature long term and stuff. So that was my original guess, right? It's like, it feels software. As someone that's written bad software, right? This feels like bad software.
Okay, so what was the process you used to get the software out of your oven and be able to look at it and see how it was written?
So the microcontroller, and it's an old Toshiba 8-bit, 16-bit microcontroller. So the first step was see, what's the security they have on it.
When you say old, what are we talking?
I think it's sort of 2000 seemed to be the release, right? So it's EOL now fully.
Okay, it's two decades old. Okay.
Yeah, 2003 maybe. I can't remember exactly, but and this is based on sort of press releases or something. So it's not hard dates, but yeah, it's been EOL at least like 4 years, I suspect now, I think.
Which is, if your oven is circa, 2010 or something, 2008, that might not actually be crazy that it would have a 6 or 7 year old microcontroller in it. But anyway.
Exactly right.
Okay. So what were the impediments to, so you got this microcontroller, it's on the back of the oven, you pull the oven out from the wall and you got the board there, the microcontroller on it. What do you do as a hardware engineer then to kind of suck the software out of it and be able to look at it and figure out what's going on?
Yeah, so the first step is always, just whatever research you can do. So in this case, get the part number off, check the data sheet. And, for this type of device, it's all public. It's not a, secure device where you then you initially run into that. But luckily the device, it had an old bootloader in it that should just work to read it out. They had a few security features they enabled. So part of the talk is talking about using power analysis to recover the password. The main Toshiba, the microcontroller manufacturer, had allowed Samsung to set a password to stop someone from reading it out. And then they had a second feature that would just disable. You could kind of set this flag that would turn off any reader write to the chip as well. So they also had set that flag. So initially I had to bypass both of those. The other problem, of course, is it's an old microcontroller, so you don't just have, modern tools don't work with it. So I also had to find and luckily I found on eBay an old dev kit for this device, which then had like the software and a programmer, stuff like that, to actually physically talk to it. So
yes,
and
shipped to you on a CD-ROM.
Yeah, an old Windows XP. It only worked in Windows XP, so luckily a little VM running.
Which also speaks to the sort of age of some of the underlying systems. And, this microcontroller might be circa 2000, but it's clearly utilizing elements that are significantly older than that.
Exactly right. And I'm sure it's just the code, has been compiled, and I'm sure it's the same, almost same code. As I said, my parents had a more recent version of this oven, and that version... it has I think it's an ARM-based microcontroller in it. So, it's a little more recent there, but it seems to have the same program flow flaw. So, right, I suspect this is like oven control.c, right, compiled for everything.
So you were able to bypass these controls, these safety locks, basically, that Samsung had put in place to prevent you from getting access to the embedded firmware. How long did that take you, and how many tries? I remember talking to like Charlie Miller and Chris Valasek about their Jeep Cherokee work, and they talked about how many times they bricked, the head end unit that they were using to try and get to the CAN bus, and having to keep bringing it back into the dealership and be like, oh, the radio's not working. So was that the case here? Were you kind of bricking your oven, or were you able to extract it without too much trouble?
It wasn't too bad. So I did make, the other cheat I did is I made a little test board. So I found because the oven control board is like $200 ish, right? If you have to buy a new one. And I made a little board that kind of had the chip on it, right, as a test. So then I could at least do it. Didn't have the firmware, but I could set similar things, do all my testing on that. Although it did turn out that there was, when you bypass one of the features, there's a chance you erase it. And on my little test board, it rarely happened. And on my, I bought that spare board off eBay, it didn't happen. But the first time I did it on the real oven, of course, it just bricked it, right? So then I think that was like 8 p.m. at night, so the repair shop locally is closed that has the part. And I was way too overconfident because my wife had actually was going to bake something, and I said, let me put the fixed firmware on it. Let's try this.
Yeah.
And then it was like, what about tomorrow?
The pressure's on.
Yeah, so it just erased. And then finally, when I got the replacement board, it turned out they only enabled one of the security features. So they stopped enabling both of them, which I think, so the feature that they originally had enabled would have prevented them from reading out anything. When I got the second board, and I suspect maybe they had some issue with returns and they wanted to see, hey, are these getting corrupted? Like the flash firmware, is it getting corrupted or something? So I think they didn't enable the second feature so they could do that analysis. This is my guess anyway.
So when you took a look at this firmware from the oven, what were you able to determine about how it was written? One of the things you say sort of in your presentation is like, our ovens are lying to us, right? So at some level, these devices are being programmed to represent a certain operating state, but that may not really reflect what's actually going on in this case in the oven. Could you actually see that happening in the code, that like the actual oven temperature was not being relayed, or it was kind of, what were you able to discern about the operation of the oven just from the firmware you extracted?
So it was interesting. You could actually find, luckily because it's a pretty simple old code, I basically wrote a little monitor that would dump, memories to a serial port that was on the oven. And with that, I could actually eventually find, where it's storing the temperature. in memory, so I could make these plots of like, here's the actual temperature, right? And actually when it's turning on and off the elements, so you could see, right, even without looking at the code flow, you could see, which is the original question I wanted to answer was, is it the temperature sensor? Because I don't think it is. And it,
And
I
it
don't think
wasn't.
it wasn't. Yeah,
Yeah.
it's right. It's reading correctly. The only thing it doesn't, and this might have been one of the reasons they have this cheat in there where they don't show the varying temperature, is when the heater turns on, I think due to electrical noise, it's like the temperature goes off by 15 or 20 degrees. It's just whenever the heater's on, instantly, it's not heating. It's just the electrical noise of that heat, I'm guessing, from the wires. So I think one of the reasons they did this firmware hack was actually to cover, because like if you're a user and you see the temperature jumping around, right?
You're gonna say, oh, the oven's broken or something's not
exactly
working.
Right. So they say in the manual, oh, don't worry, like that's just electrical noise, right? No one's gonna read that and believe them. It's
right. Talk about your fix for your oven. So what did this require you to do to get it so that it was more accurately reflecting, the temperature inside the oven itself?
So for that, once I had the code out of it, which is really just the binary firmware, right? Then it was a sort of classic reverse engineering to figure out, okay, where in this binary is any of the control logic. And there was, a few different things I tested. So one of them was just making it display the actual temperature. And so that at least lets you know when things were up. The second fix I did, which, I'll get to the issues with it right in a second. But the second thing I fixed was that the actual control logic, I basically made it stay in that preheat mode where it's actually, correctly, more aggressively controlling the temperature. So it would get back up to temp. The final issue, which I haven't fixed yet, is there's some fail-safe, I think, because right now every few days the oven just won't heat. It'll go to 86 Fahrenheit and that's it. And so you have to flip the circuit breaker. Like you can't just turn it on or off on the control panel anymore.
You have to kill the power.
Yeah. So, and the first time that happened, I was away. So my wife, I'd say, okay, well, you have to reboot the oven from the circuit breaker. And I think that'll work, and it did. But yeah, so that's the one last.
I'm imagining some conversation with your wife standing at the circuit breaker and you being like, "Well, try."
Yeah, and we just had the panel replaced, but then they I think that was at least maybe accurately marked, but a bunch of stuff wasn't too. Right?
Yeah,
so it's
yeah,
the
yeah.
plastic. Well, I think it's the double one.
When you talk to people who are like reverse engineering software or digging into stuff, you're finding all kinds of interesting stuff in developer comments or just indications about who wrote this, when it was written, things that were kind of commented out that used to be in there. Like any insights in your research into how this sausage got made? Is this Samsung code? Is this contractor code? How old is it? Like any of that stuff, or was it pretty clean?
It's pretty opaque. I mean, the thing is, because it's this old processor, they really tried to optimize for size. Because, the only reference I have is one of the passwords has Samsung in it. So
okay,
it must have been, and the board is marked Samsung with stuff like that. So at some level it is Samsung. It's not completely with ECUs how it's a different entire tier that's made it. Whether or not they internally had someone else do it, I mean, I would suspect it's probably them, based on the fact it's used in such a wide line of products.
So you added these new features. You kind of tweak the temperature monitoring sensor functionality, right? And then you recompiled the code and you basically could flash the microcontroller with the updated code. Is that right?
Exactly. Yeah.
Yeah. And it ran.
Yeah, it ran. So, and everything I'm doing, I guess I should give the caveat, right? This is all just little binary patches. So
binary
it's all
patches,
very minimal, what you can do. Like it's kind of like, okay, don't do this jump. So in the case of the temperature sensor update, you could just see where they say, oh, if we're out of preheat mode, only display 375 or whatever your set temp is, right? So you just comment out that jump that did it.
And if you were an oven owner who was not a PhD electrical engineer, is it like, how would you go about installing Colin's patch for their Samsung oven, like what would the process be? They like pull it out from the wall, like patch into that microcontroller and get their laptop and kind of upload the software. Like how would you affect that change?
So I thought about originally. So the original plan, which of course, when you're like, oh, so much time to do this, was to try to make a little, because you could run this off an Arduino or something. It's just a
Yeah,
serial protocol.
like
It's
a little
all you need.
dongle or something you could just,
Exactly right.
yeah.
So okay, press the button and flash.
Mm-hmm.
So right now there's code on the GitHub that
GitHub,
has the serial interface running in Python. So it's a little more involved. I mean, the other thing too is because it's the serial interface, you really need an isolated, opto-isolated interface because it's being plugged into your wall while it's running. But yeah, it's not. I mean, the other thing too with that is that one of the things I realized, is that if you look at any of the people doing these repairs, everyone just replaces the boards, right? There's no firmware update process at all. So there's a connector on the board for doing the firmware update. It's not documented that I've ever been able to find on the service side even, which is also pretty crazy because it's like, to either get a newer firmware update and I don't know what the difference is because I ended up erasing my oven, but I could see the checksum of my original oven firmware is different from the checksum of the new oven firmware.
Right. So there's been a modification at some point.
Yeah, right. So maybe they fixed some of the issues. Like it didn't seem everything, but
right.
It would make sense, right, that they would have had newer versions. But so the thing is, I'm sure people are replacing their boards. They don't even need a pack or anything, right? They just want a firmware update. And yeah, I mean, I'm kind of curious because the microcontroller is EOL. It also has the question, are they going to stop making more of the boards?
Right.
Right? Like, are people not going to be able to get spare parts for their oven?
Right.
And maybe all it needs is a firmware update.
Firmware update. You don't even need a new board, right? You can just do this. Yeah, totally without. And as you know, obviously replacing the board, even though it's better than replacing the entire oven, but you're still creating a fair amount of e-waste when you could solve this problem much more simply with a software update.
Right. And the software update, maybe that's something people can do, if they're techie and have a serial interface thing. It's like they can fix
or here's a crazy idea. Maybe oven makers can start to make it easy to do this type of stuff, right? Because that will prolong the life of the device. So that brings us to the sort of the other aspect of your talk that I think is so interesting, and I'm so glad Black Hat took you, is presenting you, which is this whole larger conversation around repairability, circularity, prolonging the useful life of devices. And you point out in your presentation that one of the consequences of this funky temperature sensor feature is that a lot of consumers who aren't PhDs in electrical engineering are going to say, I'm not going to, reverse engineer this and patch the code. I'm going to I'm going to get rid of this thing, throw it in the trash, throw it in a landfill and get a new oven that doesn't have this problem. Whereas, as you've shown, you don't need to do that, right? There's a way to get, to correct the workings of this software and get the equipment to be much more functional than it is as shipped by the manufacturer. So I'm really like, is there a business model, right, for what you did? I mean, you talked about if we had a dongle and so on. Like, is that a possibility? If not with this device, maybe other devices are going forward.
Yeah, I'm sure there must be. I mean, I'm terrible with this because I always have ideas that are 60% executed. So, of course, I thought a little bit about this and I was like, oh, no. Now something else is interesting. So no time for that. I'm sure there would be. I mean, I know, for example, on the automotive side, there's tools for reflashing like airbag computers and things, because once the airbags go off, the computer becomes invalid. And so I know there's people that sell tools and that's their whole purpose is like, it's physically fine. You just need to reflash it. And they charge people to, every time, I don't know how exactly, it does a flash or there's a big cost of getting the tool. I'm sure for oven repair techs, like, again, because Samsung doesn't even tell you that this is possible to reflash them, right? Or, if you wanted the code added to debug so that you could actually see, hey, what is the temperature sensor? You don't have to go replace everything. You just plug in and you can dump, the temperature's off. Like, there you go. I know to replace that, not spend all this time, right? And to your point of people replacing them, I'm sure there's lots of techs that have come over when people have this oven, they say they have this problem, and this tech's going to say, well, I can try to fix it, but I'm going to have to replace the temperature sensor. And if it's not that, that's going to be
Mm-hmm.
$50. I'm going to replace the control board. That's 200. And it could be the element. Oh, there's 100, right?
And
You're
then
going to
you're
be
like,
$500 in, and it
mm-hmm.
might not fix it. I can't even guarantee, I'm
Mm-hmm.
positive they've had that conversation because the tech doesn't want to, most of the time they don't like just throwing parts at it and
Well, and
hoping.
they'll do what they're trained to do, right? I mean, most techs are going to run down a checklist of likely problems and what's most likely and start there. If they're not trained to say, oh, hey, there's this logical port, you can flash the software, here's an update, then
Mm,
they're not going to do that, right? I mean, well, you don't do what you're not trained to do,
yeah.
and you
Yeah.
definitely don't want to take the risk, right?
Exactly, right. That's
Right.
it. Like,
Yeah.
you're not going to say, "Oh, let's get this random guy's code." And don't worry, customer. I
Right.
trust him.
Exactly. Talk about how does it work now? How did it work before with the temperature sensing, and how does it work post Colin patch?
Yeah. So the main issue, so the number one issue with this seems to be they basically, I mentioned at the beginning, I thought maybe they'd do this PID controller, which would be your standard, right, really nice temperature controller system. What they do instead, and my friend that's more into industrial told me this once, and then now I've forgotten what he told me exactly, of course. So people are going to listen and say that's not quite right, but it's a pulse control, right? So it's like it has a fixed pulse width heater, and you can see it just does these pulses.
Right.
Um, and I'm guessing, I don't know if that's because the element, you don't want it on all the time or whatever reason. But the issue with that is that the pulses are too narrow to actually recover. So if you put a big load in, like a big turkey, and the door's open for a few minutes, so the temperature's dropped, it doesn't have enough power in that mode to ever
Right.
recover. In preheat mode, it just turns on the element more or less solid. So in that mode, it gets up to temperature really fast, and then it tries to just maintain. And it's the maintenance mode that's problematic on mine.
Right.
And it could be, so the other thing you can get is like if the element is a bit broken, or my theory is it's a bit worn over. These are older ovens, it's aged, so the kind of parameters they tuned for have
No
shifted.
longer. Right. Right.
And if this was a PID controller or something that had more feedback in it, I think it would recover more reasonably. Those are designed to sort of account for this. Um, so that was the fundamental problem, was it just wouldn't get back up to temperature if you had a big load in, and it seemed to be because of this. And what I did is I basically leave my oven in preheat mode now, or the
Mm-hmm.
firmware, so it's doing much more aggressive pulses. So the time it turns on for is longer. It works. It looks a lot more like a classic mechanical thermostat. It's over temp, do nothing. It's under temp, turn on. So you get a bit more of a ripple, but it's averaging right on what you want instead of before where it was slowly going down.
And here's a big question. You've done a couple tests. I noticed shepherd's pie, some souffle. What's the experience been?
It seems good. So, I mean, to be honest, we had to recalibrate a bit because without realizing it, you get so used to the fact that it's under,
Yeah.
we've been cooking stuff hotter. So,
Hotter. Right.
so
Yeah.
we've had to recalibrate a bit with that. Yeah. And the other issue right now is still this problem. And it only seems to happen when you first turn it on, where it just won't heat at all and needs to be rebooted. So
Yeah. You
that's
needed.
still, and part of it might be, I did add this monitor code I mentioned, which was more serious. It uses some memory that might be used elsewhere. I kind of took a guess.
Right.
So it may just remove that. Obviously for cooking, I don't need the monitor. That was purely for debug and testing.
One of the things that's really interesting to me about this research is I think it speaks to kind of how the sausage is being made right now in the the appliance world, the personal electronics world, right? Which is, I think we all have this sense of manufacturers like Samsung or LG or even Apple. That mean they're always using the best components, and they've got the smartest software engineers working for them, which like at a high level is true. But it's like Upton Sinclair, the jungle, right? When you go into the sausage factory, onto the floor, and see how it's being made, like in this case, you're like, well, they're using a really old microcontroller, with a really old processor that can't really handle that much. And so, they're actually having to make design choices about this software based on the limitations of the hardware. And that's, they're making compromises, right? And, like you said, like, they've got this port, they could be doing software updates and that type of maintenance, but they're not, they're kind of not doing it. They're not training their techs to do it, so they've structured this whole kind of product lifestyle cycle in a way that's very suboptimal, right? That most people would look at that and be like, well, you're not really doing everything you could be doing to support this thing, and in fact, you made a whole bunch of junky design decisions based on this junky old hardware. Like it's like the sausage factory, you're like, hey, you just pick that piece of meat up off the floor and put it in the sauce. Like, you can't do that, and like your research really, for me, sort of like synthesizes all that. Like, yeah, like when people like you peel back the covers of the software locks and the DRM and actually look at, what's going on, often it is this kind of Upton Sinclair's jungle, like, ooh, like, what a mess.
Yeah. Yeah. No, and it's interesting because, so coming maybe more from the design engineering side too, right? There's a lot of these things where, I mean, especially in the embedded space, it's funny, people that don't have the embedded design background get into it, and you'll see their talks and they'll be like, oh, like the embedded designers, why did they do this crazy thing that's, totally terrible and insecure? It's like, oh, I know, because I would do that exact same thing, because I just took the manufacturer's example app and compiled it and like was done. Right. Perfect.
Made a couple
right?
tweaks.
Like I've definitely done that. No question.
Yeah.
But yeah. And sometimes it's, there's constraints within the company. So a while back, I did some stuff looking at Philips Hue, and they had this issue where their bulbs were using
the light bulbs, smart light bulbs. Yeah,
exactly. Yeah. And they use the same key across all the bulbs, right, for the firmware, which isn't a great idea. And the thing is, they go to the server and they ask, like, hey, server, give me the latest version of firmware for this product. So they 100% could use a per device key. And, they have it's like smart engineers working there, them. And I never actually asked in the end, but I 100% know, right? Like a bunch of engineers, I'm sure, were like, yeah, this is a bad idea. We should be doing per device key, of course, or at least per product line key or something. Right. And I'm guessing it was just a cost, right? Cost of maintaining this larger update infrastructure for securely more securely doing it. So, it's also a lot of the case where people are giving these designers impossible constraints, right? Either on the cost for the consumer product has to be below X, right? Even if it was 10 cents more and they could add this more secure device or whatever it might be, right? But yeah, it's interesting too, because like clearly, and you can never know for sure, of course, not being in the company, but a lot of the time it looks like, this was an artificial constraint that the engineers made work.
Right. It just shows you, like, they're, the process of making these products and writing the software, like, you got a lot of things that you need to do. And if there isn't a really top-down process of saying, well, let's go through, what you've done with a security eye, with a sort of red teaming eye on how would a malicious actor look at this, what types of things would they be probing around at, then it's easy for stuff to kind of slip off your radar as a engineer, right? You're trying to just get features done, check them off, and move on.
Yeah, completely right.
Yeah. So have you had any contact with the manufacturer, with Samsung or Samsung engineers or anything?
I haven't yet. I didn't, a while back I'd reached out, but I didn't push that very hard. It's such the microcontroller on the Toshiba side is EOL for, a while. So in fairness, they shouldn't.
So let me ask you, what is the big fix for this in your mind? I mean, I again, the 10,000 foot level version of what you've explored here is, the manufacturer put kind of not very high quality software on their home appliance. It was causing problems for owners, but there was no really easy way to fix it. You just happen to be technical enough to actually go in and fix it yourself. What in your mind would be like kind of the big fix for this, across product categories, across the economy, right? These types of problems that when you really look under the covers, they're really software problems. And, the manufacturer is often the source of the problem, not the solution, or maybe the source and the solution.
Yeah. Yeah, it's a good question. I mean, if you could solve all of that, you're really solving poor software design in general. For these, I think for me,
good luck with that.
Yeah, right. And I guess maybe it speaks to, lots of the question of how do you even know if a product does what it says it should do, right? You get consumer protection, right, is basically it, which is maybe easier when it's a physical, I don't know, a door that doesn't open, right? Or it catches, and in a fire, your door doesn't open. There's going to be a recall. But I think software has become so complex and nebulous, right? That, what is the way that consumers can say, I mean, this class action they were trying to do is really how I guess people are trying to solve it, right? That way, because like you look at the complaints have been going on for years.
Yeah.
Right?
The other is just to have independent software providers, right? Like you, who can come along and say, hey, Samsung she'll do an oven with crappy software on it. We've got an update. We got a version of software that will not only fix that problem, but add this feature and that feature, and kind of maximize the potential of your hardware, right? We don't really have that so much. Like you buy a piece of hardware and you just assume that it's always going to run the software that it came with.
Yeah, no, you're completely right. I mean, and I originally had thought of could I make an open source, oven controller for my oven software, and then have a better, PID.
Do it.
Yeah. So I'll see. I mean, the issue is that there's, then I realized then there's the variance of this other microcontroller. Although if you had an abstraction layer, it might not actually be too bad, because it's, and to be honest, most of the buttons, on my oven at least, it has all these buttons I've never pressed, like chicken tenders button and all this stuff. So, most of the time, the only feature I use is convection bacon, right?
Yeah. Bacon broil, maybe.
Yeah, broil, right?
Yeah.
So it's like really what you'd have to implement.
Right.
I don't think that much.
Final question is, if other people are listening to this and like, oh, this is really cool, I want to get more into like learning about, the embedded software that might be running on my, oven or my dishwasher, like where would you suggest that they go and start digging around?
Yeah, so I mean, if they're interested, so I've posted a bunch of stuff specifically to my oven, which might be really interesting to people, just to see, hey, what's this actually look like? So my blog, colino'flynn.com, has a link to that, to the GitHub. There's a bunch of links below it. So it'll be at Blackhead. I also co-authored a book, the Hardware Hacking Handbook. So Jasper, who's at a company Riskier that does very similar stuff at sort of a higher level, and I wrote this book, and it talks a lot about how do you even get into it in general, right? Which is like ripping the cover off and playing around. And for a lot of this stuff, it is just, I mean, as a kid, taking things apart and looking at what's inside it, right? With the caveat, eBay is really nice for this because, as in my example, the oven control board and oven is really expensive. So you can buy an eBay one, poke at that before you, get your partner less happy with you.
Colin O'Flynn, thank you so much for coming on and speaking to us on the Security Ledger podcast.
Thanks so much for having me, Paul. It's been a lot of fun.